Welcome and very good afternoon to all of you, dear friends. So today we are taking up the last chapters of the mathematics portion, and that is differential calculus. So I'm sure you are keeping fine and following the sessions very. I'm sure you're following it very clearly, and you are able to understand all the important topics which are being covered, along with the solutions to different questions. So today we are taking up differential calculus, and the next and the last chapter will be integral calculus. So the first point is you have already covered the chapter on sets, relations, and functions. And I'm sure you have got a very good understanding of that chapter. Why? Because that chapter is the foundation for us to study integral calculus and differential calculus. Why? Because calculus deals with functions. Therefore, you must have got good understanding of the different type of functions. And when we talk of functions, there will be functions which are continuous functions and functions which are discrete functions, right? So we will first enter into differential calculus today. Calculus is of two types. It is differential calculus, the first part, and the next part is integral calculus. Now, what is calculus, or what is differentiation? Now, let me take a small example, friends. Now, say I am writing let y equal to x square plus 1. So I've written a function. Y is a function of x, right? Why is it so? Why is I've written y equal to x square plus 1. So it means y is a function of x, because once you know the value of x, you can find out the value of y. So friends, two important points we shall note. First, I'm writing in the notes part. First, we will understand functions, the basic concept. Then we shall see what is the dependent variable and the independent variable. Okay, one by one we shall see. Y equal to x square plus 1 is, of course, an equation. And here we can say that y is a function of x. But the question is, which one is the independent variable and which one is the dependent variable? Here, if you see x is the independent variable. So I will write independent. That means x can assume any values, but the value of y will depend on the value of x. So here y is the dependent. Okay, it is the dependent variable. For example, if I write, say, let's say x equal to, say, 1. When x is 1, y will be how much? 1 square plus 1, that is 2. When x is, say, 3, it will become 3 square, that is 9 plus 1, 10, y equal to 10. That means I can say that the value of y is derived from the value of x, right? So therefore, x is the independent variable, y is the dependent variable. Why it is called a variable? Because you see, they can assume, x can assume any function, any number, right? It can be fraction, it can be negative number, it can be a positive integer, right? So therefore, x is always the independent variable if you see this equation, and y will be the dependent variable. Now comes the question that if we try to find out, right? If we try to find out what will be the change in one variable with respect to the other variable. So here you see differentiation, which we write as, in short, DIFF. Differentiation means they are trying to find the rate of change. Rate of change. Now, rate of change of what? Rate of change in the dependent variable with respect to a small change in the independent variable. So we saw that y is what? The dependent variable. So I'm writing dependent, DEP, short form of dependent. And x is equal to the independent variable. Okay. So the purpose of differential calculus is to find out the rate of change in y. So I'm writing rate of change short form as ROC. So differentiation or the entire body of differential calculus, the entire subject, is based upon the basic principle. And what is the basic principle? The basic principle says that the differential coefficient or the process of differentiation, or there is another term which we are writing here, and that is called derivative. Derivative. So derivative, which is always written as dy by dx, this measures the rate of change. So the rate of change in y with respect to a rate of change in x. Just try to understand. So it deals with rate of change in one variable with respect to the rate of change in another variable. And of course, you can see that the rate of change, the ROC, the rate of change, is measured as delta y by delta x, which means we are trying to find out that what will be the change in y due to a change in x. Now, let me take a simple example. Okay, let me take a simple example. So, let me take the example of something which you all know. Okay, let me take the example of demand and supply, right? Demand and supply, you are learning in economics. Now, you see, if my income changes, right, the demand which I have for a particular commodity will change. Right, I was discussing in my earlier session that now you see the petrol prices went up, so much of inflation going up, coming in the economy. So when my salary is same, my income is same, but when the price of commodities moves up, then what happens? I'm unable to buy. That means there is a change in the demand of that particular commodity because of a change in the price. So you know that as price moves up, okay, as price goes up, the demand will fall. Similarly, if my income goes down, say I lost my job during the COVID pandemic, or my salary has been reduced, I'm not getting the earlier salary. So if there is a salary, if the salary goes down, right, I will not be able to buy so much of commodities, right? I will have to cut down my expenses. So what will happen is, as the salary goes down, right, we can also say that the consumption, I'm writing consumption also goes down. So here, salary and price, these are the independent variable. And based on the price, the demand changes. So demand is the dependent variable, right? So if I break down the entire column into two parts, just for the sake of understanding, this side, the left-hand side, and here we have the right-hand side. So the left-hand side of this side is basically what we are dealing with, the independent variable. Salary is an independent variable. But if the salary changes, the change in the consumption, that will be dependent. So my consumption depends on my salary. How much I will buy, how much I will spend depends on my salary, right? Try to understand. So therefore, consumption is nothing but the dependent variable. So I can write that on this side, what you see is y. This y I was talking about, dependent. This side is the dependent part. This side is the independent variable. Okay, so as price increases, the demand will fall. As salary decreases, consumption will also reduce. If my salary increases, if I'm lucky enough that my salary increases, or if I'm lucky that I get a new job, my consumption will also increase. So these are related. They are related. So they are linked. Okay, they're related. So we can see that differentiation, or the concept of differential calculus, basically talks about two things. We are trying to see what is the change, or what is the rate of change in the dependent variable due to a small change in the independent variable. right? Now, if you talk about something like, say, economics, yes, in economics, I was giving the example of demand, supply. Similarly, you know that there is a sort of relation between supply and price, right? Now, what happens is, as the supply goes up, what happens is price will fall. So there is a relationship. So here also we can think of X and Y. So we can say that price is a function of demand, price is also a function of supply, and therefore price depends on demand, price depends on supply, which also means that demand, or rather, if I say price, for that matter, price, if I think of price as the factor X, which is independent, the demand will be the factor Y, which is dependent on the price. Okay, so primarily calculus, we will see the differential calculus component, the first part which we are doing today, and we are going to complete the entire chapter today, deals with the concept of derivative, which I have written here. And derivative means nothing but dy by dx, which measures, this dy by dx measures the rate of change in the dependent variable, which is y, with respect to a small change in the independent variable. But please remember one thing, I'm sure you've discussed about it in your last session, that we can always find the derivative, that is dy by dx, in case of a continuous function. So this is possible only in case of a continuous function. Okay, a continuous function, say if I want to graphically draw a continuous function, that means, say the function graphically is like this, which means in between 2 points A and B, the graph is continuous. Please see, the graph is continuous, right? That means there is no point of discontinuity. That means between the point A and B, the graph is continuous. There is no break in the graph. There is no sudden discontinuity in the graph. That means the function is continuous. That means for any value of x within the range of A and B, right, we will get a corresponding value of y. So you have discussed, I'm sure, about the range, domain, codomain, etc. So I'm sure that you have understood this concept of continuous function. Please remember that the differential coefficient of the derivative can always be found provided the function is a continuous function. Now comes the question of the formula. Now we will see what is the formula for differential coefficient. So till now we have seen that differentiation, there are two parts of calculus. One is the differential calculus, which talks about the rate of change in the independent variable x, delta x, due to a small change in the independent variable. What will be the corresponding change in the dependent variable? So for a small change in my income, what will be the corresponding change in my consumption? Okay, dy by dx, or delta y by delta x. This triangle, you know, is called delta. Delta means small difference. Similarly, if my income moves up and down, say my income goes down, my consumption will go down. If the price goes up, right, the demand will fall. So if price is considered as an independent variable, x, right, then demand is a function of x. So demand is y, it is a function of x. So due to a small change in the price of a commodity, what is the corresponding change in the demand of that commodity? Now, this is very important. You can understand. If you're running a business, many of you might be thinking that why calculus is there in our curriculum. Now, you see, in economics, which is a very important paper of your curriculum, even in IPCC, you have to study economics. We have a full paper. I think, we are having a 50 marks component, entire component on economics. Now, economics is important for finance. To understand financial management, to understand the entire business landscape, you must know economics. And economics talks about, primarily, I'm saying, demand, supply, production, cost, etc., which you are studying also. And if you are a business person, you are running your business, the first thing you want to know is how sensitive the market is. That means if you think that, okay, now we are having a recovery from COVID, slowly the economy is running smoothly. Now, can I increase my price? Say you are selling certain commodities at 10 rupees per unit, right? Now, you are deciding to increase the price to 12 rupees. So you must know, before you increase the price for decision-making purpose, you must know that if I increase the price from 10 to 12 rupees, here price is the independent variable, that means X. You will definitely be interested to know that if I increase the price by 2 rupees, what impact, you see, what impact, what outcome will it create on the demand? Because you are ultimately thinking of demand. How much will people buy? That is something you want to know. I hope you're getting the point. So this is the basic reason that we are studying calculus, right? So the rate of change, please remember the derivative I'm writing here. The derivative measures the ROC, the rate of change in Y with respect to X. So the rate of change in the dependent variable due to a change of the independent variable due to a small change in the independent variable, which is X. Now we shall see the formal, the formal relation, which we all need to know for the purpose of differentiation. So please see, I have taken some practical examples of consumption, income, demand, and of course, we talked about what is a continuous function. I talked about the practical parameters. So we saw what is a continuous function. Now, differentiation or differential calculus deals with rate of change. Now, how do we, when we think of this dy by dx, which we have written, I was writing dy by dx, which is actually delta y by delta x. Okay. Now we will see the example through the formal definition or the formal formula, whatever you call it, right? So dy by dx is equal to function, right? Please see carefully, function x plus h minus function of x divided by h, and h is tending towards 0. And here we also write the word limit. This is dy by dx. So dy by dx means the original function was y equal to fx. Please see, fx. The original function is y equal to fx, right? Now, there is a small change, okay? There is a small change in the value of x, and we are calling it x plus h. So if the value of x changes, say now x becomes x plus h, and h is very small. Please see, limit h tends to 0. That means h is a very small amount. It is moving, it is tending towards 0. So it is almost equal to 0, but not 0. It is almost equal to 0. Very close to 0, but not exactly 0. So h is tending towards 0. So we have the new value of x is x plus h. So now the function will be, the new function will be y dash will be equal to function of x plus h. So the new value of the function is fx plus h. And the original value of the function was fx. So fx plus h minus fx divided by h, this tells you, this gives you the dy by dx, that is the differential coefficient. This is also called the derivative. So always remember, as I said, that it will only be applicable for continuous function. Once again, I'm explaining continuous function. It is actually the last chapter on sets, relations, and functions. This continuous function concept is there. I'm sure you know about it. Cover. So here the idea is between any 2 points, say 2 and 6, right? Any 2 points, 2 and 6. There's a graph like this. Now, this is a continuous function because for the value, say x is equal to 2 and x is equal to 6, between this range, right? You can see there is no discontinuity in the graph. There is no break in the graph. But if the function is like this, there's a break. So this break you see, that means the function is not continuous, it is discontinuous, because for certain value of x, there is no value of y. Please see, this is an empty area, empty. It's empty zone, right? So up from here to here, yes, the line is continuous. There's a break. And again, from this point to this point, the line is continuous. But there's a break in between. So for a certain value of x, if I put x here, I won't get a value of y. This means the function is not continuous, right? So I think you can understand this is the concept of continuous function, and derivative is always, right? Derivative is always important, and it is always possible to find dy by dx provided the function is continuous, right? Okay. Now let us see. This is a very important chapter, and you have to also remember number of formula, which we will see one by one. But please remember this basic introduction, this basic interpretation of differential calculus, that dy by dx is nothing but measuring the rate of change. The rate of change in what? The rate of change in the dependent variable with respect to a small change in the independent variable. Here, independent variable is x. So y is a function of x. Y depends on the value of x. So y is a dependent variable, right? Similarly, in this example, h tends to 0, which means the difference, the original function was y equal to fx. And the value of x, we have taken x was, say, for example, the value was x. We have taken x as the original value. Now, if the value of x increases by a certain amount, so it becomes x plus h. So the new function will be y dash equal to f of x plus h, right? So therefore, this is the new value. Okay, we can call it, say, y2 also, and this is y1. So y2 minus y1 divided by h, which is the small amount. That means with respect to a small change in the independent variable, what is the change in the dependent variable? That is what we're finding out. The numerator, if you see clearly, just think, you can watch the video again and again later, but you can see that if you see this numerator, the numerator basically deals with nothing but the change in y, delta y. What is h? H is the change in x, so I can say it is basically delta x, right? So this is how we write the derivative of any function y equal to fx. It is written in this way. Now let us take an example and see what will happen if I take certain functions. Okay, so I will take a simple function. Let me take x square. Let's take x square. Okay, and see. We will try to use the same formula. I'm rubbing it out. I'll write it again. And the more number of times I write, you will also see. So you will be able to pick up the entire concept. Now say, let y equal to x square. Okay, we want to find out dy by dx when x is equal to 3. So at the value x is equal to 3, we shall try to find out what is the value of y equal to x square. So basically, we are trying to find out when x is 3, what is dy by dx. So instead of fx, of course, y is a function of x, so I can write y equal to fx, which is equal to x square. But now I want to find out the differential coefficient when x is 3. Okay, therefore, we will just write function of 3, f3. That means instead of x square, I will write 3 square. Okay, so the formula was dy by dx was limit h tends to 0, function of x plus h minus fx by h. This is what I wrote earlier, and this is the fundamental procedure to write the concept of differential coefficient. dy by dx is formally fundamentally written as this, where h tends to 0, fx plus h minus fx deals with the specific change in the dependent variable, and h denotes the change in the independent variable. Okay, so here we will just substitute x by 3. So I will write like this here, the next step, limit h tends to 0, right? The difference tends to 0. I will write here, instead of f x plus h, I will write 3 plus h, but we know it is whole square, x square. So I will write 3 plus h whole square minus fx. Fx is x square, but here x is 3. So I will write 3 square divided by h. Okay, I think it makes sense. You can follow 3 plus h whole square minus 3 square by h. Let us expand this and see what we get. Limit h tends to 0. Okay, 3 plus h whole square, that gives you 9 plus h whole square plus 6h minus 3 square, that is 9, divided by h. So 9 and 9 cancels out. I am getting h square plus 6h by h. Okay, or I can write it like this. Limit h tends to 0. The solution comes h square plus 6h by h. So if I take h common, I get h plus 6, and below also I get h. This h is here, and if I take h common from here, I get h plus 6. Since h is not equal to 0, if h is equal to 0, we cannot divide by 0. But since h is not equal to 0, h is tending towards 0, but not equal to 0. So we cancel h and h. So what we get, h plus 6, but h is tending towards 0. So this effectively becomes 6. So the differential coefficient of y equal to x square at the point x equal to 3, the answer is 6. Okay, so this is how we find out the limiting value, and the limit is the value which y gets as x approaches 3. That means as x is moving towards 3, y will move towards 6. In this case, the coefficient of y, differential coefficient. Okay. Now we will take one more example. Let me take 4x cube. We take a bigger example now, a longer one. We take if fx equal to 4x cube, what do we get? So please follow this fundamental formula which we are doing now, and otherwise, there are shortcuts, there are a number of formula which we need to remember. We will look at that, we will understand each of them, but this is a fundamental concept which we must never forget. Okay, so if y is equal to 4x cube, okay, the same process has to be followed. That means you will write limit h tends to 0, 4x cube. So I shall write 4 into x plus h whole cube minus 4x cube by h. And then I have to expand this full, expression. There will be certain cancellations and certain adjustments. And finally, if you work it out, let's see what we get. So limit h tends to 0, 4 into x plus h whole cube, that means 4 x cube plus h cube plus 3x square h plus 3xh square minus 4x cube. So this 4x cube and this 4x cube gets cancelled out. So what I'm getting is divided by h. What I'm getting is limit h tends to 0, right? 4, okay, 4 is outside, so I will write, let's multiply and see what we get. So 4 into h cube, so I will write 4 into h cube plus 4 3s are 12 x square h plus 4 3s are 12 xh square divided by h. So let's take h common from the numerator. So this is equal to limit h tends to 0, From the numerator, I take h common, so I get 4h square plus 12x square plus 12xh by h. Since h is tending towards 0, but h is not equal to 0, so therefore we can cancel this h and this h. Basically, we are dividing by h, so we cancel it out. So this gives us the formula. What we are getting is 12x squared. We are getting 12x squared plus 12xh, but h is almost 0. So this 12x into h becomes, as h tends to 0, this will be also equal to 0. And this 4h square will also will also tend towards 0 because h is tending towards 0. So what we are getting is 12x squared. So 4x cubed, the differential coefficient of 4x cubed is 12x squared. From this, we will see some formula, right? So this is a pretty long chapter, and please note that you have to also understand the concept of, apart from differential coefficient, you also have to form this, apart from this particular formula, you also need to know about the different other formula, which are shortcuts, of course, shortcuts for your exam. So if you try to, if it is given in the exam that dy by dx, where y equal to 4x cubed, yeah, this process is, of course, foolproof process, but it will be time consuming. Okay, so we have the shortcuts, but then you have to remember few of the formula. I request you to note it down, just simple formula, it will help you. So let me first take up, okay, Shobit, you are asking what is h in the formula? Yeah, h is nothing but the difference in the value. So h is, you can see h is the difference in fact, I will say the increase or the decrease in x. Of course, we have considered an increase. If x changes from x to x plus h, this h is the differential value of x. X is the independent variable. Okay. Fine. Okay. So you can see, let me see what Mausam. Ananya has got 12x square. Okay, Supratha, no, we will be using the formula, of course. This long method is only for the understanding in the study material also. If you see, the Board of Studies has explained the concept of differential calculus by this expression, by this formula. So we have understood this. Now we will move into the basic important shortcuts, right? So it will be useful for you to remember them so that you can apply them in the exam. When a question comes in the exam, you have to apply the formula directly. This definitely will not be useful in the exam because this is only for understanding purpose. And without understanding this step, right, this delta y by delta x, which I was writing, and the rate of change, unless you understand this entire step, we cannot understand the formula or we cannot memorize the formula. So that is why I think this is important. Now, what we have done here is 4x cubed, but since x has increased, it has become x plus h. So instead of x, I have written x plus h whole cube minus the original formula for the original expression 4x cubed divided by h. Okay, then we have expanded a plus b whole cube, a cube plus b cube plus 3a square b plus 3 into ab square. I have just written the formula minus 4x cubed, but now this expression multiplied by 4. So I get 4x cube here. This 4x cube cancels with this 4x cube. And what we get is 4 into h cube, 3 into 4, 12, x square h, plus 4 into 3, 12, xh square by h. After that, I have taken h common. So what I'm getting is from 4h cube, if I take h common, I will get 4h square, 12x square h, if I take h common, I will get 12x square. From 12xh square, if I take h common, I will get 12xh, right? So now I cancel h with h because h is not equal to 0. H is only tending towards 0, but not equal to 0. But as h moves towards 0, okay, as h moves or tending to move towards 0, what happens is 4h square moves towards 0 also. So I can write, just in short, maybe I'll just rub up this part so that you understand the last part of my logic. As h tends to 0, if h is moving towards 0, 4h square, which you see here, this will also move towards 0, right? Similarly, 12xh will also move towards 0. It will also tend towards 0 because h is moving towards 0, right? So as the value of h becomes smaller, moving towards 0, 0.00000001, okay, it becomes smaller, 0.10 zeros after that 1. So what will happen? The practical value, this will all become 0. So we will only get 12x square, and that is the final differential coefficient. Okay. Okay, I hope Mosam, you have understood this. Right. Now, Shweta, you have said that h tending towards 0 means h can come towards from the negative side as well as from the positive side, right? That means instead of say x equal to say 5, okay, it can be the new value of x can be 5 plus h, it can also be 5 minus h. But now for the simplicity part, we are assuming that x, the value of x increases from 5 to 5 plus h. But that h, the value of h is very small. We call it infinitesimally small, infinitesimal, right? Infinitesimal means very, very small. Okay. Vishwabandhu is asking, trigonometric, will it come in derivative? No, trigonometric functions are not there in your exam. Okay. Okay. Right. How 6h is coming? Christy is asking, where are you getting 6h? We have not got any 6h anywhere. It's 12x square h plus 12xh square. 6h we have not got anywhere. Okay, 4x cube, it is coming to 12x square. Right. Now let's carry on with the, the presentation and the discussion. Okay, now we will see the formula. Straight away, this will be very useful for your exams. And when a question comes in the exam, you have to apply the formula. This was only for the purpose of your understanding, right? So continuous function we have seen, dy by dx we have seen. Now we shall see the formulae. Okay. The first one is number 1, d dx of x to the power n. Okay, differential coefficient of x to the power n. That means here y is equal to x to the power n. So dy by dx will be equal to, please note, x to the power n. The differential coefficient will be n into x to the power n minus 1. Okay, so this is the first formula. Let us write each of the formula, then we shall see what will be the applications and the numericals we shall be doing. Okay. Then let us take, let me take few examples first. Okay. So let me take, if y equal to 4x, okay, what will be the value of dy by dx? Okay, so this can be written as y equal to 4x, so I can write it as 4 into dx by dx. Okay, because instead of y, I will write 4x, but 4x, the 4, the constant part, I bring it out outside, and I write dx by dx. Now, dx by dx basically here means 4x means what? X is to the power 0. X is to the power 0. Okay, so x is to the power, sorry, x is here, for x is to the power 1. Sorry, x is to the power 1 because we have x means x to the power 1. So now what happens is, the formula is nx n minus 1. So here x is 1. So I will write 4 into 1 into x to the power 1 minus 1. nx n minus 1. So it is nx n minus 1. So it becomes 4 into x to the power 0, which is 1. So it is 4. Please see that you have to follow the rule of the law of indices to solve this. So if I give you a question, typical question in the exam, say if x is equal to 6, or let me put it this way, x to the power 7, what will be the value of dy by dx? So if y is equal to x to the power 7, what is the value of dy by dx? X to the power n. Differential coefficient is nx to the power n minus 1, right? Nx to the power n minus 1. So this will be equal to 7 into x to the power 7 minus 1. That means 7x to the power 6. Okay, so this is an important formula which you have to remember. Similarly, if I take another example, say y is equal to 4x square, right? So dy by dx is how much? Okay, so dy by dx, we will write 4 first, and then we write d dx of x square. Find x square, that is x to the power n. Here n is 2. We know the formula, the differential coefficient of x to the power n is nx n minus 1. So this will be 4 into nx, 2. Here n is 2. So 2x to the power n minus 1, that is 2 minus 1. So it is 4 into 2, x into 2, x to the power 2 minus 1 means 1. Okay, so x to the power 1. So this is 8x. Answer is 8x. So 4x squared, the differential coefficient becomes 8x. So this is the first and important formula. Now, another important point. So I'll just rub out the examples because we need space to write the major formula. And for every formula, we will do these problems. So if it is x to the power n, dy by dx is equal to nx n minus 1. The next formula is the differential coefficient of a constant c is always equal to 0. If c is a constant, the differential coefficient of a constant is always equal to 0. And in other words, we can say derivative of a constant function is 0. Now, if you want to derive all these, if you are asking, if you think how these are coming, right, then you have to use that first formula which I wrote, fx plus h minus fx divided by h as h tends to 0. You have to put all these expressions, right? You remember how I did the earlier problem where I said that I think we found out the derivative at x equal to 3 function was given. So that's fundamental formula which I wrote here, that is fx plus h minus fx by h, limit h tends to 0. This is the mother formula. This is the parent formula. This is the formula for differential coefficient. Any function which you get, say y equal to c, which is a constant, or y equal to x to the power 5, you can put that here and you will get the formula. If you want to derive, if you really want to derive, if you want to find how the formula is coming, x to the power n is equal to the differential coefficient is nx n minus 1. How is it coming? If you wonder, if you are really curious, then you can do it using this formula, right? But for the exams, of course, we have to remember these ones. This is only for conceptual understanding so that you are clear about differential coefficient. Differential coefficient measures the rate of change in what? In y for a small change in the value of x. Here, x is the independent variable, y is the dependent variable because the value of y depends on the value of x. A very good example, which I was sharing earlier, is the change in the demand due to a change in the price. Here, price is the independent variable. Demand depends on price. So demand is y, price is x. Okay, I hope you're following and understanding. Now we take a very simple formula, which is just in a few minutes you will understand. So if there are two functions, the addition of two functions. So we are trying to do d dx. Say we have fx plus gx. Okay. So this will be very simple. We just differentiate the functions separately. So it will be d dx of fx plus d dx of gx. Okay. So we just do it separately. Similarly, and this I'm writing 3 and 4 because the same formula is applicable for subtraction, plus minus. So here also it will be plus minus. That means if you're getting something like this, let me take an example. Say you are given that you have to find the differential coefficient of 6x square minus 7x. 6x square minus 7x. So this will be the differential coefficient is equal to 6x squared. 6 will remain as it is x squared, x to the power n. So it will become nx n minus 1. Nx to the power n minus 1. So it will become 2 into x to the power 2 minus first part. Now I put the minus sign here again, 7x. 7 I bring out, we have x to the power 1. So it will be 1 into x to the power 1 minus 1. So I get 6 into 2, that is 12x. X is having the power of 1. And here I have 7 into 1 into x to the power 0. Anything to the power 0 is 1. So this is 7. So the coefficient, the differential coefficient of 6x square minus 7x is 12x minus 7. Okay, let me take one more example. This was for subtraction. Now we shall take a particular sum on addition. Okay, and let me take an exam question. Okay, so I'm taking an exam question. Okay, 2 exam questions. Okay, I'll take 2. Okay, so y is equal to, fine, let's try it out. Y is equal to 2x square plus 3x plus 5. 2x square plus 3x plus 5. You have to find the differential coefficient. Simple, dy by dx will be equal to 2x square. 2 comes out, x to the power 2, x to the power n, this formula, nx n minus 1. So I will write 2 into x to the power 2 minus 1 plus 3x. 3x means 3 will come out, x to the power 1 minus 1 plus 5. 5 is a constant. So using formula 2, we know the differential coefficient of a constant is 0. So I will write 0. So this becomes 2 2s are 4x plus 3. X to the power 1 minus 1 is 0. So x to the power 1 minus 1 is x to the power 0, which is 1. So we get 4x plus 3. Right? So dy by dx of this particular function is 4x plus 3. This is an exam question. We will take one more. Okay. So once you remember the formula, it becomes very easy because there is nothing. The formula are very simple, of course, and virtually, if you note, if you note this particular chapter, functions, right? Functions and differential coefficient, continuity limit, and all. Just by the formula, you will be able to understand, right? Just you remember the formula. Okay. Saundarya, you are asking why you wrote dx by dx, because if y is equal to x, okay, then dy by dx will be equal to what? Dx by dx, which is 1. Okay. Dx. Y is equal to x, say for example, so it will be dx by dx. So if we are getting, I wrote dx by dx because the question was y equal to 4x. So I wrote 4 outside into dx by dx. So 4 into 1, which is 4. Okay. Shirisha, some of you are asking questions about the CA Tube channel, when you will get the recorded sessions. I think you please have to talk to Board of Studies. I'm not aware when you will be. There is some IT disruption, which I heard also. But I think the best person is to, if you can talk to the Board of Studies, they will advise you when the channel will be live, active, and you can see the recorded. You can see the recorded sessions, right? Yeah, Suprada. Yeah. Yes, all the formula emerge from that. You are asking all the formula will emerge only from that fundamental formula which you are using, right? Now, I had a science background before I took up CA, so I had to go through all the formula, including trigonometric functions. But fortunately, in CA, you don't have trigonometric functions, right? Let me take this one. Yeah, I said I will take another one. This is a long one. It came in the exam, but it seems to be, like very it will, once you see the problem, you will feel, oh my God, it's such a long problem. But no, you just break it up using this. The formula, the question is, if y is equal to x to the power 7 minus 6x to the power 4 plus 3x square minus 9x. Okay, so minus plus minus. You have to find dy by dx. Okay, fine. Just by applying formula number 1 and 3 and 4, we will solve it. So first is x to the power 7. So this will be, I'm directly writing 7 into x to the power 6. X to the power n, nx n minus 1. 7x to the power 7 minus 1. So it is 7x to the power 6. Minus 6. X to the power 4. So x to the power n. Here x to the power n is x to the power 4. So n is 4. Okay. So I will write 4 into x to the power 4 minus 1. That is 3. Then I have plus. So I will follow the plus sign. Plus 3. 3 will come as it is. X square. X square means x to the power n. Here n is 2. So the formula is nx n minus 1. So I will write 2 into x to the power 2 minus 1. At the end, I have minus 9x. This will be equal to minus 9 into. Okay. Once again, dx by dx. So 1. 9 into 1. So the expression will be 7x to the power 6 minus 6 4s are 24, x to the power cube plus 3 into 2 is 6, 6x minus 9, minus 9. Okay, this is the answer. Right. Now we move on and see some more functions. Okay. Let us try this one. Okay. Simple one, but little twisted. Okay. You have y is given 5 divided by 2 to the power x cube. So how to deal with this? You have to find dy by dx. It is given that y is equal to 5 divided by 2 to the power x cube. So can I write it like this? You tell me if I am right or wrong. I will write like this, 5 by 2. Okay, 5 by 2. X to the power 3 means x to the power minus 3. 1 by x to the power 3 means x to the power minus 3. Am I right? You are having good knowledge of indices. You can tell me if I'm doing correctly or not. So 5 by 2 x to the power minus 3. Right? I hope it's correct. So again, the same formula. This will be 5 by 2 x to the power n. So nx n minus 1. So I will take minus 3 n x n minus 1 minus 3 minus 1. So this will be minus 3 into 5 is how much? Minus 15. Minus 15 by 2 x to the power minus 4. So I can write it as minus 15 by 2x to the power 4. Minus 15 by 2x to the power 4. See if you can follow it. Okay, so here x is in the denominator, x cube. So once you move 1 by x cube to the numerator, as per the law of indices, it will become from x cube, it will become x to the power minus 3. Okay, so 5 by 2, 5 by 2, n x to the power minus 3 is of the formula of the form x equal to y equal to x to the power n. So that is equal to n into x into n into x to the power n minus 1. So minus 3, I have brought x to the power minus 3 minus 1. N x to the power n minus 1. Minus 3 x to the power minus 3 minus 1. Okay, so we have in the numerator minus 3 into 5, that is minus 15. 2 is the denominator, 2 comes here. And x to the power minus 3 minus 4 means x to the power, x to the power minus 3 minus 1 means x to the power minus 4. So I've written x to the power minus 4. This, when you reverse, it becomes minus 15 by 2. In the denominator, we get x to the power 4. Right? I hope this is clear. Fine. We'll take one more example of a different type and see. Okay. So now you are given that y is equal to square root of x. You have to find dy by dx. So square root of x I can write as x to the power half. Simple. So this is of the form x to the power n. So dy by dx will be x to the power n, n x to the power n minus 1. Okay. So it will be half into x to the power half minus 1. Half minus 1. So this is half to the power x, half into x to the power minus half. Half minus 1 is minus half. So this is equal to 1 by 2. X to the power minus half means 1 by x to the power half. So it is 1 by 2. And you can leave it, I think you can leave it in this way, or you can write 1 by 2 to the power x. 1 by 2 into x, x square root of x. Okay, because this means half, and the denominator it will become x to the power half. X to the power half is square root of x. Okay. So you can also deal with these type of questions using the simple formula x to the power n, which I wrote here, and this is the application. Right. Now we shall take one more formula, and that is the product rule, which is important. Okay. So we have taken the sum as well as the. So we took this. The sum rule we have done, the subtraction rule we have done, division rule. I'm writing one by one as I complete each of the points. Product rule means two products. So two expressions are given, two functions of x. So if I write like this, that d dx of u into v, where u is a function of x and v is also a function of x. So please remember this formula here. Say if I write that y is equal to u into v, where u is a function of x, v is a function of x. You have to find out dy by dx. So this dy by dx will be equal to, first, what we will do is, first we are going to take u outside, and first we will differentiate dv by dx. Plus, we will keep v outside and we will do du by dx. So please remember the product rule and the division rule. There are some differences which you need to know. And the product rule, in case of the product rule, please remember u is the first function, v is the second function. First function is kept outside. We deal first with the second function. We find out the differential coefficient of the second function. Plus, I put the second function outside and I find the differential coefficient of the first function. Okay, so this is for multiplication. Now we will take an example to see how we find out how we apply the product rule. Okay. Let me take the product rule. Achha. Before that, we will do some more. We'll just write some more formula. Okay. Yeah. Let me write here, and then we will take the product rule. We have seen the product rule. We'll take the product rule. I'll write formula number 5 we have done is the product rule once again. Formula 6 is, let me do some important formula. d dx of e to the power x is always equal to e to the power x. You have to remember this. E here means, which you have seen, E, we will deal again in statistics when we discuss about one important theoretical distribution, that is the Poisson distribution, which is there in the curriculum. E is nothing but the Euler's constant. It is called the Euler's constant. Approximately E's value is approximately equal to, right? Just as you know, pi, there's a value pi, 22 by 7. So E is 2.718. It is known as Euler's constant. And E, which you see here, is also known as the base of the natural logarithms. You have done logarithms exhaustively, I'm sure, so I'm not going into logarithms, but you know that logarithm is of two types. We have the natural log and we have the logarithm to the base 10, right? Now, e is logarithm to the base e. So if you have something like log a to the base e, this is the e. So e to the power x, the differential coefficient will always be the same e to the power x, no change. Original function and the differential coefficient will be the same. Right. One more, of course, is number 7. So let me take this. We will look at some standard formula and then we shall see. Yeah. If you are given ddx of a to the power x, okay, a to the power x. So a to the power x, the differential coefficient will be, you have to remember these formula. It will be a to the power x log a to the base e. Okay, a to the power x log a to the base e. Right, so we have seen the first formula, x to the power n is equal to n into x to the power n minus 1. The second formula was the differential coefficient of constant term is 0. The third formula is the addition of two functions. If you have to find out the differential coefficient of two functions which are added, you have to find out the differential coefficient separately, right? Similarly, if there is formula number 4 deals with the subtraction, fx and gx, two functions of x. If you are getting a function like this, y is equal to fx minus gx, you have to find the coefficient, differential coefficient of y with respect to x. So how do we do it? We just do ddx of fx minus ddx of gx. So we just separate them. Okay. So this is formula number 4. Formula number 5, we did the product rule. We will do numericals on that. Formula number 6 is if you are given e to the power x, ddx of e to the power x, that is the differential coefficient of e to the power x, the answer will be e to the power x. Please remember, e is called the Euler's constant. It is roughly equal to 2.718 Euler's constant. Okay. And then we have the 7th formula, a to the power x, where a is a constant. A to the power x, we will get the relation a to the power x log a to the base e. And now the last one I'm writing here is if you have to find out the differential coefficient of e to the power ax, e to the power ax, the answer will be a into e to the power ax. So you have to remember these 8 fundamental formula. In integral calculus, yes, there will be some more formula, quite a number of them, I will tell you, and you have to remember them. Of course, the weightage in the exam is around 10 to 15% for these chapters, right? So E is a mathematical constant. Once again, it is called the Euler's constant. It is the base of the natural logarithm, and the approximate value is 2.718. So these 8 formula we have to remember. Of course, the 9th formula will be the, okay, what I'll do is product and division. If I consider as one formula, then we have these 8 important formula. X to the power n, this gives us n into x to the power n minus 1. The differential coefficient of a constant is always 0. ddx of two functions fx plus gx is basically the sum of their individual differential coefficient. So ddx of fx plus ddx of gx. Similarly, formula number 4 will be fx minus gx. So there also we will do ddx of fx minus ddx of gx. Then we have the product rule and the division rule. Division rule we will do. 6th formula is e to the power x, where e is the Euler's constant. The answer will be the same. 7th formula is a constant to the power x. So the differential coefficient is a to the power x, same term, into log a to the base e. And finally, ddx of e to the power ax, where a is a constant, it will be a into e to the power ax. Right, so these are something we have to remember. And these are also called the standard formula. Fortunately, trigonometric functions are not there. Otherwise, it would have created further problem because, sine theta, cos theta, cot theta, cosec theta, there are a lot of complications there. Okay. Now, let me take, yes, we will take some formula for, one more is there. Yes, log x. Okay, I think we will get a round whole number of 10. So ninth formula is, I'll write it here. Ninth formula is ddx of log x. Log x. The answer is 1 by x. Simple to remember, it's 1 by x. The 9 formula in all till now. Okay, I think 1 or 2 formula we will also be able to add, will make it 10. So we go back to the product rule and let us take the product rule and let's work on it. Okay. Sum and difference we have done. So we'll take the product rule and the division rule. Right. Fine. So we have seen all the 9 formula now, and these 9 formula we have to remember and apply them one by one as we carry out the solution to problems. Okay, so we have seen 9 formula up till now, I'm writing, and then we will apply them. Fine. Okay, so there's one question from the exam. Y is equal to a to the power x, okay, a to the power x plus x to the power a plus a to the power a. What will be the differential coefficient? Please see the question. You have to find the differential coefficient of y. Okay. Yes. Yes, yeah, Suprada, there are some formula, 10 formula at least, round, 10 fingers, right? You have to remember them. Otherwise, questions are going to be quite easy from this chapter. But if you remember these 10 formula, yes, I can you can be comfortable about any question which you get. So let me try to solve this using the 9 formula which we have written. I'm trying to remember all the 9 formula and we will do it. So dy by dx, directly I'll do. A to the power x, we know that it is basically a to the power x log a to the power x log a to the base e, please remember, plus x to the power a, this will be just, this is a into x to the power a minus 1 plus a to the power a to the power a is a constant, so it will be 0. So the answer will be this much. Okay. Now let us take one more example. Okay, very simple example. 3x square plus 5x minus 2. Very simple. 3x square plus 5x minus 2. One step solution. 3 2s are 6x plus 5. I think some of you can follow. 3 into x to the power n. N is 2. So 2 into x to the power 2 minus 1. So that will give me x. And this 2 into 3 gets 6. 5x. 5 comes out. ddx of x is 1. So 6x plus 5. Okay. We do some product formula now and see. So in case of product formula, as we talked about, if you are given d dx uv, okay, the product formula, please remember that first, where u is a function of x and v is also a function of x, kindly remember that u has to be first kept outside. So no fighting with u. U remove. U is kept us outside. So u is out. First differentiate v. Then you keep v outside and then fight with u. Okay. So the first person don't fight. Fight the second person first. So first person kept out, fight with the second person. In the second expression, keep the second person outside, fights with the first person. Where u is the first person and v is the second person. Yeah. Or the first function and the second function. Now let's take Okay, let's take a long, quite difficult example and see if you can work it out. Oh, this is big one. I won't keep this. We will do the problem without referring to the formula. See, that is the fun of maths. Challenge yourself and do it. Y is equal to, this is a long one, don't be afraid, just relax and solve. Y is equal to 3x square minus 1 multiplied by x square plus 5x plus 2. This looks a bit long, but is not so. It's a case of product. Okay. So please see that this part, I can say u and this is v. It's a product. U is also a function of x. V is also a function of x. Just have a look at the problem and see whether you understand. Okay, u is a function of x and v is also a function of x. Okay, Saundarya, you are asking how do we get to know which formula we have to apply? Just try to see, Saundarya, just trying to see the given expression. See, from this expression, Saundarya, I think you are following. You have asked, I'm responding to your question. So you see, this is what you ask yourself. Will it be addition formula? No. Will it be subtraction formula? No. It is what? It's multiplication. One expression into another expression. So u into v. So it will be the product formula, right? Now we will break it up into product formula, right? Now let me try it out, okay? So we know what to do. First, we know the formula. In case of two functions u into v, first fight with the second person. So I will keep 3x square minus 1 outside and first differentiate the second expression. So what I will do, dy by dx will be equal to, first part I will keep outside. 3x square minus 1, I will keep outside. I will find ddx of this one. ddx of x square plus 5x plus 2. First part, plus. Now what I'll do, I shall be keeping, in the first example, I kept u outside. So now I'll keep v outside. So v is x square plus 5x plus 2. X square plus 5x plus 2. And I will do the differential coefficient of the first expression, that is 3x square minus 1. Okay, this breaks into what? 3x square minus 1 as it is. ddx of x square plus 5x plus 2. Now you can do it yourself. This will be equal to x square, differential coefficient is 2x. So I write 2x. 5x, differential coefficient is 5 plus 5. 2, differential coefficient is 0 because 2 is a constant number. Okay, so 3x square minus 1 into 2x plus 5. This is the first expression simplified. So this entire lot now comes into this much. Now we will take the second part which you see here, I'm circling, the second part. So I write plus, and now I have x square plus 5x plus 2, which is outside this part, ddx of 3x square minus 1. 3x square ddx is how much? 6x, 3 into 2 to the power x, 2 to the power 2 minus 1. So it is just, I write 6x. That's it. Now we simplify. So if you simplify, just multiply now, 3x square minus 1 into 2x plus 5 plus this whole lot. Whatever you get will be the answer. If you just try it out, you can just try it out and see 3x square minus 1 into 2x plus 5 plus x square plus 5x plus 2 into 6x. Right? You can leave the answer here or solve it out depending on the options given, but this is the process. Okay, we take one more. Product formula, this time little different, and we'll try to see how to use the product formula. And the question given is, the question is e to the power x log x. Now just see, is this what is this question? Is it a addition rule? No. Is it a subtraction rule? No, it's a product rule. So e to the power x into log x. So e to the power x is the first function u, log x is the second function, which is v. So as per our strategy, what we do is we first keep the first formula is kept out. The first expression is kept out. So dy by dx is equal to, first I will keep e to the power x out. Log x I will carry out, ddx of log x. Plus, now I will keep log x outside, I will do ddx of e to the power x. Right? So this is log x. We saw one of the formula, log x, the differential coefficient is 1 by x. So this will be e to the power x by x plus log x as it is, e to the power x. We know the differential coefficient of e to the power x is e to the power x itself. So this is log x into e to the power x. So if I take, let me take common and see what I get. So e to the power x by x plus log x to the power e to the power x, log x into e to the power x. So if I take e to the power x common, I have 1 by x plus log x. Okay, this is the answer. Okay, so this is again an exam question. Right. So we have done number of questions on the product rule. Now we will take the division rule. Okay, division rule. Division rule is almost the same, just one small difference which you have to keep in mind. So here we are doing d dx of u divided by v. In the earlier example, you were doing u multiplied by v. Here we are doing u divided by v. Okay. Now u is a function of x, v is also a function of x, and you have to find the differential coefficient of u divided by v. Now in the last example, we saw that when there was a multiplication of two functions u and v, what we did was we first kept u outside and we first targeted v. We did dv by dx. We carried out the derivative of the second function. Now here it will be the opposite. So here what we will do is, first we will, in the first product rule, what we did, once again, u into v. We kept u outside and we targeted v. Here it will be the different part, just the opposite. So here what we will do is ddx of first, we'll keep v outside. First we will target the first person, u. Minus, instead of plus we have a minus here, minus u into ddx of v divided by v square. So this is the full formula which you need to remember for the division part. Just have a look at the formula. Okay, number of questions will come on this. So kindly note that many of you are giving right answers. Okay, Jagan, Janvi, Isha, Supradha, Ananya, many people are giving right answers. Good. Okay. Yeah, Puneet, we are just doing the basic formula only. You are asking the basic formula. These are the 10 basic formula, right? We are doing that only. Hope you are following. These are the 10 basic formula which you need to keep in mind, and from there only you will be able to solve all the questions. Okay. Now let us see some examples. Okay. So please remember the fundamental difference between the product formula and the division formula. In the division formula, what we do is we target the first expression. But in case of ddx of uv, what we did was we kept u outside and we did dv by dx, plus we kept v outside and we targeted du by dx. But here you see it's just the opposite. Product formula, the first expression is kept outside. Division formula, the second expression is kept outside. Product formula, the sign is positive. In the case of division formula, the sign is negative. Product formula, the second part, we are targeting the first expression du by dx. In case of the division formula, we are targeting dv by dx, which is the second expression. du by dx is the first expression, dv by dx is the second expression. Plus, in case of product formula, there is nothing in the denominator. But in case of division formula, you have v square in the denominator. Okay, these are the two differences which I thought of sharing by writing the two formula side by side, or top and bottom. Now let us try and do one example using the quotient or the division rule. Okay, so we are taking this question and solving it according to the formula given. So it's given that let h equal to 2x by 3x cube plus 7. You have to find dh by dx. This we don't know, you have to find it out. Please see the question. So we've given h is a function of x, h is given by 2x divided by 3x cube plus 7, and you have to find dh by dx. So first question, the rational approach, the logical approach is to identify which formula to use. Is it addition? No, there's no addition. Any subtraction here? No. It's a fraction like 3 by 6 or 3 by 8, like a fraction. A fraction means division. So I know that I have to use division formula, right? Multiplication not the case, addition not the case, subtraction not the case. It is a case of division, right? So I will use division formula. Clear? So what we do, let me just try it out. So the differential coefficient dh by dx will be equal to, first, in this formula, what I do, in the case of multiplication, we knew that we used to keep u outside. Here we will keep v outside. So 3x cube plus 7 kept outside. du by dx. So we will do ddx of 2x, which is 2. Now I'm doing directly. Minus this minus. U is kept outside. U is 2x. So I keep 2x here. ddx of 3x cube plus 7. 3x cube plus 7 gives you 9x square. So 9x square. Divided by v square. V is this. So 3x cube plus 7 whole square. So if I break it up, what I'm getting, if I simplify, 2 into 3x cube, that is 6x cube. 6x cube plus 7 2s are 14 minus 2 9s are 18x cube by 3x cube plus 7 whole square. So I'm getting 14 minus 12 x cube by 3x cube plus 7 whole square. Right? So 3x cube plus 7 into 2 minus 2x into 9x square divided by this whole. So this is the direct application of the division rule. Just have a look at the solution once again. Okay, so we have seen the product rule. We have now dealt with the division rule as well. Fine. Logarithmic functions, we have seen that log x, ddx of log x equal to 1 by x. Right. E to the power x we have seen. Also a to the power x we have seen. Fine. Okay, now we will see some extra questions which are important in the exam also. And we will see implicit function, parametric functions, and the remaining portions of this chapter. Right. Otherwise, once you know the formula, it's very interesting and just an application of your mind. And questions will be quite moderate from this chapter, looking at the past year's trend. Right. The questions will be just based on formula. Okay. The question is differentiate log. So you have to differentiate log 1 plus x square with respect to x. Okay, so in these type of questions, that means you have to find out this ddx of log 1 plus x square. Okay. This is the question. So what we do is we simplify. I'm writing let 1 plus x square. Okay. So I write it as this, let 1 plus x square is equal to p. 1 plus x square is equal to p. Okay. So this becomes what? It becomes log 1 plus x square becomes log p. So this, if I just find out log p, d log p of dp will give me 1 by p. Okay. But the question is, I have to find out what? I have to find out log 1 plus x square, what is the differential coefficient, right? So in other words, dy by dx can be written as dy by dp into dp by dx. So this part I have done 1 by p. Now dp by dx. Okay, dp by dx. That means I have to find out the coefficient of this part, dp, 1 plus x squared. 1 plus x square, if you find the differential coefficient 1, differential coefficient is 0. X square, differential coefficient is 2x. So 2x. So the answer basically will be 1 by p into 2x. But p is how much? 1 plus x square. So the answer is 2x by 1 plus x square. Just see how we have solved it. So these are special types of questions, and techniques have to be used like this. Okay. Now, implicit functions. We will take implicit functions, section 8A of 8A5 of the study material. Implicit functions. Okay. Just right, we are doing implicit functions. Implicit functions. We will also do parametric functions. Okay. So functions concept we have done. Dependent variance we have discussed. Continuous function I have shown. Formula, we have taken the fundamental formula. We have done the subtraction part, addition formula, product formula, division formula, all the 9 formulas, including logarithmic differentiation, e to the power x, a to the power x we have seen. Then we've just done a special case of differentiation. Now we are doing implicit. Now, implicit function, say an example is given that if a function is of the form fxy equal to 0, then it is called implicit function. Okay, so x and y together. Now, I'm giving an example. Let's take a very common example. X square y square plus 3xy plus y equal to 0. Okay, so you can see from here, y cannot be separately defined as a function of x, right? X and y are combined. It's very difficult to define y as a function of x. In this case, we have to find out the differential coefficient. So this is called implicit function. Implicit function. We'll try to find it out. So our question is x square y square plus 3xy plus y equal to 0. We have to find out what is dy by dx. Now, you can see the first expression is a product. Again, 3xy is a product. So now we will differentiate. So differentiating step. The step is now differentiating. X square into y square. So it is of the form uv. Okay. So we know in case of product formula, keep the first function outside. Deal with the second function first. So I keep x square outside. I'm doing this one. And what I do is I find out d dx of y square. Plus I take y square outside and I find d dx of x square, but that is 2x. So my first part is over. plus I'm taking 3xy. I keep 3 outside. xy, xy. So here it's a product rule. uv. Here it's xy. So I keep x outside. X dy by dx plus I keep y outside. Dx by dx is 1 plus y. So I take dy by dx. This is equal to 0. This 0 comes here. Now we have to just simplify and see what we can do with this. So we have, if you see the first expression, we are having the first expression is x square into 2y into dy by dx. Okay, 2y. 2y because y squared, so 2y, but we have to find out dy by dx. Plus, we have here 2xy square. So I write 2xy square plus 3 into this whole expression, that is x dy by dx plus y plus dy by dx. So x dy by dx plus y, and outside also we have dy by dx. This is equal to 0. If you simplify, you will get not a very good round figure or a normal, easy looking answer. If you simplify, you will get dy by dx is equal to minus 2xy squared plus 3y divided by 2yx squared plus 3x plus 1. Okay. So this is implicit functions, how to differentiate implicit functions. Right. Let me take the chain rule now. Parametric functions. Yes. Now we'll do parametric functions. Okay, we just have around half an hour to complete, and we will look at our parametric, and then we directly go into the last component, which is basically the applications and from economics. Fine. So now we take parametric functions. Just rub this out. Parametric functions. Okay. Now, in case of parametric functions, now if you have x and y, which are expressed in terms of a third variable, it is called a parametric function. Now, the third variable, you can call it a parameter. Now, say if I write, say if x is equal to at cube, at to the power 3, and y is equal to a divided by t to the power cube. The question is find dy by dx. Just see the question. X is given a into t to the power cube, and y is given that it is a divided by, right, y is given that it's given that y is equal to a divided by t cube. You have to find dy by dx. So what we do is, we first, this dy by dx is equal to dy by dt into dt by dx. Dt cancels, dy by dx remains. Dy by dt. So let us take first one. Let's differentiate the first one. Dy by dt. So dy by dt is equal to d dt a divided by t cube. A divided by t cube. Please see, you know the formula, you know the expression. Let us just solve it. So this is equal to a comes out t to the power minus 3. So I can write it as minus 3 t to the power minus 3 minus 1. Okay, I can write this as in this form. So this becomes a minus 3a t to the power minus 4. First expression, I will keep it under a box and call it 1. Now we find dx by dt or dt by dx. Okay. Now, basically, dt by dx is equal to 1 by dx by dt. So let me find dx by dt and then I will invert it. Dx by dt is equal to d dt of at cube. So this is very simple. This directly comes to 380 square. This is expression number 2. Okay, so the final formula is 1 divided by 2, because we have got dx by dt. I will have to get dt by dx. I have to invert it, right? So 1 divided by 2, and this I will do here. The final solution I will do here. So 1 is what? What is 1 minus 3at to the power minus 4? This is the first expression. Second expression is 380 square. 380 square. So this will be what? This will be divided, right? So if I want to divide or invert it, 380 square will come in the denominator. So this 3 and 3 cancels out. A and A cancels out. I'm left with minus 1 divided by t to the power 6, because this minus 4 will come to the denominator as t to the power 4. And we already have t to the power square. So it will become t to the power 6. Okay, please see the solution once again. This is called parametric function. Okay. Parametric. So we have done the implicit function. We have also covered parametric function. Okay. Now we see multiple differentiation, sometimes called differentiation of higher orders. So up till now we have taken a function and we have found out the differential coefficient dy by dx. But what happens if we differentiate the function once again? So d square y by dx square. Again, if we differentiate, we get d3y by dx cube, dx3, like this. So let us see how to do that multiple differentiation. Right. Okay. Some of you are asking log question, how to find log question, Sahil. Okay. Example of log, I took that example. You know, you remember e to the power x log x, we took that example. Suprata is asking, should we simplify the answer? It depends on the options which are given. You have to see the options. If you find that the options are in such a way that the expressions are simplified, then you have to simplify the answer. But if you find that the options are given in a way which is not fully simplified, that means they have just multiplied the two expressions, then you can keep, you don't need to simplify further. You can just keep it as it is and match the correct answer. Okay. See, many people are asking questions. When you are asking questions, please try to understand our situations also. Hundreds of questions coming, and we are doing a tough chapter. Plus, we have to complete within 2 hours given time, right? So, as I said earlier, it's not possible to take each and every question. If I do it, I'll overshoot the time, right? So please understand, and please again be a little bit considerate, because you know the purpose is not to answer each and every question. Not possible. Some questions are again repetitive questions, right? And as I said, if I start answering the questions, we will overshoot the time. We will not be able to complete the chapter, and then again you will have problems, right? Let us take the next question and see what we have. Yeah, Veni, I have taken the example how to, there's no trick, you know, u v dx, you have to remember that you keep out u first, u into v dx, right? Right? V is the second function, plus keep v outside and do du by dx. That is the simplest way. Okay. Mahadevan is asking whether all portions will be covered. I don't know whether there'll be revision class. Board of Studies will be able to give you the right answer. Okay. We are not yet having any information regarding revision classes. Already, I think you have got the schedule for the March session. So I think March we are going to do statistics and logical reasoning. and we are trying to complete these last two chapters, which is differential calculus and integral calculus, with which we shall be completing. Okay. Ria, I don't see your question. You are writing, why are you not answering me? This is not the way to write, number one. And number two is, I have not seen your question, right? So please be courteous when you are asking questions. Take care of the language also. That's important. Okay, fine. Let me see the next question and carry forward. Multiple differentiation. Okay. Parametric is done. Now we'll take multiple differentiation. It's given that y is equal to 3 by x. 3 by x. We have to find d cube y by dx cube. That means we have to differentiate it 3 times. So y equal to 3 by x, let me find dy by dx first. I keep 3 outside, so I get d dx of 1 by x. That means x to the power minus 1. X to the power minus 1. So this means 3 into minus 1, x to the power n. X to the power n. The answer is n into x to the power n minus 1. So this is minus 1 into x to the power minus 1 minus 1. Be very careful about the sign. Differential calculus is not an easy chapter. It requires practice, and there are applications of indices. There are applications of basic mathematics. Formulas are there. This is the shortcut. At least I don't know of any further shortcuts. No further tricks are available. Right? If everything in life, if everywhere we have a trick, we search for the shortest route, we will not find shortest route everywhere. There is no shortcut to hard work. There's no shortcut to multiplying. I mean, memorizing these formula. UV dx, there's no further shortcut. You have to remember that. And this is only possible, as I always say, practice, practice, and more practice. 3 ways: practice, practice, and practice. Nothing else. No magic is there in mathematics, right? So you have to remember the formula. Here again, there is no shortcut, no thumb rule. Wherever there are shortcuts, I told you, compounding, rule of 72, rule of 114, rule of 144. That's a shortcut. Here, no shortcut, sorry. So we have to do it. You can see I'm working step by step. So here we have minus 3, minus 1 into 3, x to the power minus 2. So I have got dy by dx. Now I will calculate d square y by dx square. That means second order differential coefficient. Okay. So minus 3x to the power minus 2, minus 3 will go out. X to the power minus 2, that means x to the power n. The formula is n into x to the power n minus 1. So that is nothing but minus 2 into x to the power minus 3. 3 into 2 is 6. Remember to change the sign. Minus and minus becomes plus. 6x to the power minus 3. Now I will go for the third one, d cube y by dx cube, the last step. So I will take 6x minus 3 and I will differentiate d dx of 6x minus 3. So the question is, I will take minus 3 outside and 6 x to the power minus 4. X to the power minus 3 means x to the power n, which means nx n minus 1. So minus 3x minus 3 minus 1. So if I write this here, it will be minus 3 into 6, that is minus 18x to the power minus 4. Or you can write it as minus 18 divided by x to the power 4, whichever way. So this is the third order differential we have done. So let me write, after parametric function, we have covered the third order differential, that is d cube y by dx cube. I'm keeping a track of everything which we are completing, so that there is no confusion later on that something is not done, something is done, whatever it is. Okay. Yeah, many of you have got it. Ananya, Shivangi, correct. Now we go to last part and we look at the economics part. But before that, we just try to see the concept of tangent and how the differential coefficient is used. Now we look at the tangent and we see how the concept of differential coefficient is actually used. Now you see, if there's a curve like this, Tangent means, like if I draw a circle here, tangent is this. Okay, this line is a tangent. This is a circle, 90 degree, 90 degree. This is tangent. So if I write AB, AB is the tangent. Circle center is O. So here also in this graph, the tangent will be at this point like this. Tangent is nothing but dy by dx. Just remember that tangent formula is nothing but dy by dx. Okay, so I'm writing tangent. We are doing the tangent part. So tangent is dy by dx. So if you're given a particular equation, which is, of course, it has to be, ideally, it will be, you will see in the exam also, it will always be an equation with order 2 or 3. So quadratic or a cubic equation. And from there, you have to find the gradient or the tangent. Tangent is also known as gradient. Gradient. Gradient means the slope. It's basically the slope. Okay. Gradient. So if I say like this, say 90 degree, 90 degree, A, B, C, X, Y, Z, X, Y, Z, two triangles. Which triangle has the highest or higher slope? AB, very flat, 45 degree. This is around 30 degree. But here it's around 75 degree. So this triangle has steeper slope. The gradient is more. Gradient is higher. Okay. Think of a mountain. Mountain is like this. Easy to climb. But think of a mountain which goes like this and, so steep, gradient is more, steep, very difficult to climb the mountain. Slope, if it is flatter, easy. So this is a triangle with a lesser slope, and this is a triangle with a higher slope. Gradient is less, gradient is more. Now let's take the question and we will see, it's an exam question. We'll try to see the solution to this question. The question says, find the gradient to the curve. The curve is given y equal to 3x square minus 5x plus 4. And they are saying that the point will be 1, 2. That means find the gradient of the curve at the point 1, 2. Very simple. We just consider this to be a curve and we find the differential coefficient. So directly we write that the gradient or the slope is given by dy by dx. So we carry out d dx, 3x square minus 5x plus 4. So this comes to, straight away I'm doing 6x minus 5. 6x minus 5. We have to find the slope at the point 1, 2. That means where x is 1, right? X is 1. So I just put that x equal to 1. So 6 into 1 minus 5. 6 minus 5, that is 1. So the gradient is plus 1. So the gradient is plus 1. Okay, this is basically the concept of gradient. Okay. Now, applications of differential calculus, last portion, we look at the applications. Now, in case of applications of differential calculus, as I said, economics, most important thing. So if I look at the apps, the applications. Okay, now and the applications, so tangent, we have done apps. So in the applications, first is, definitely I'm not going into physics because physics is outside our study, but I can only tell you that in physics, just think of acceleration, right? Your car accelerating or a plane taking off and accelerating. So their acceleration, F, is always given by dv by dt, where v is the velocity and t is the time. Acceleration is nothing but the rate of change in velocity over time. When you buy a car, people always say, how fast is the car? What do you mean by how fast? That means how high is the pickup? You always see that whenever there is an advertisement of a car, let me draw a car with an aerodynamic shape. Okay, say I'm drawing a car with an aerodynamic shape like this. Aerodynamic, so like an aircraft, okay, aircraft, like an aircraft. Aerodynamic, nose is pointed. So everybody asks the question, how far the car can accelerate. Nowadays, you see the companies will tell you, whether it's Honda or whether it's Volvo or whether it's Hyundai or Maruti, everybody will tell you 0 to 100 kilometers per hour in 6 seconds. Just giving an example. Another car manufacturer says 0 to 100 kilometers per hour in 9.5 seconds. Which is the faster car? The first one. 100 kilometers. 0 is the initial speed. Final speed is 100 kilometers. But the rate of change of speed is how much? Just calculate. dv by dt. That is 100 by 6. How much is that? Let me find out. Then you will understand the practical application of calculus. 100 by 6 is how much? Say around 7. 100 by 6 will give you, say, approximately, let's calculate both of them. 16.67. This is car number 1. Car number 2 is saying 0 to 100 kilometers we will cover in 9.5 seconds. So here acceleration is dv by dt, which is 100 divided by 9.5. So how much does it give you? 100 divided by 9.5. That gives you 10.52. Which one is better? Which one is faster? Just check. Which one is faster? Obviously, car number 1 is faster. So acceleration means the rate of change in velocity with respect to time. Similarly, you can see, so acceleration F can be written as dv by dt. So in physics, in aerodynamics, in aviation engineering, this has a wide application. Now we come to our area. Now I've just talked about the application in physics, because you see calculus is studied everywhere by chartered accountants, by physicists, by engineering students, everywhere. So definitely it has applications in engineering. It has applications in physics. Okay, it has applications specifically in aeronautical engineering. Now with respect to economics, definitely we deal with price, quantity, demand, and supply. These are the basic things we deal with. And I was discussing, of course, that as price increases, consumption will decrease. As supply increases, S increases, right, price will fall. These are fundamental relationships. So what will be the rate of change in the consumption if there's a rate of change in price? So it is nothing but, if I write consumption as C and price as P, the rate of change, ROC, will be given by dC by dP, where DC, C is the consumption, P is what? P is the price. Very similar to acceleration. Okay, so it's basically any change, any rate of change in demand with respect to change in income, rate of change of revenue with respect to change in price. Price changes, revenue will change. By what? By what? What will be the impact of that? What will be the rate of change? So these are the applications of differential coefficient. So we will take the last example, last 2-3 examples before closing out on applications of this branch of calculus. Now, you all know about marginal cost, marginal revenue, that is MR. You know the concept of total revenue, total cost, average revenue, and marginal cost. MC, MR, you know, AC, AR, you know, right? So when I talk about cost and revenue, we have total cost, here we have total revenue. You have average cost, here we have average revenue. You have marginal cost, you have marginal revenue. So based on this question in the exam, model test paper question, now it is given that a firm is having a demand, and the demand is given by, P is equal to 17 minus 3Q. 17 minus 3Q. We have to find, this is the demand. Okay, this is the demand where Q is the quantity. We have to find what will be the total revenue, number 1, and what will be the marginal revenue, number 2. Okay, just see the question. Firm is having the demand. So I'm writing here in application, we are doing demand, supply, cost, production type of examples, right? So we have 17 minus 3Q is the demand equation. Just have a look at the question where Q is nothing but Q is the number of units. Okay, Q is the number of units. Now the question is total revenue you have to find out. Let's take the first question. Total revenue is how much? We know that total revenue means the number of units Q into what? Into the demand. That is price. Here P is basically price, right? And it is given by a firm faces the demand curve P equal to 17 minus 3Q, where P is the price and Q is what? Q is the units. So total revenue is equal to Q into P. That means Q multiplied by 17 minus 3Q. And this is equal to 17Q minus 3Q square. So this is answer number 1. 17Q minus 3Q square will be the total revenue of this firm. The second question is we have to find marginal revenue. So the first question we have solved. The answer is this, 17Q minus 3Q square. The second question is marginal revenue we have to find out. How to find the marginal revenue? So marginal revenue we can find just by DDR. So we will take DQ and we'll take 17 minus 3Q here. So marginal revenue is nothing but the derivative of the demand, or whatever you can see here, the demand equation of the price. So the marginal revenue, you know, means the revenue obtained by selling one more article. That is marginal revenue. So this is given by 17Q. So we will take this into the Q because you know that marginal revenue is equal to DDR, right? Just a second. DDQ of the total revenue. Differential coefficient of the total revenue will give you the marginal revenue. So here we have the total revenue we have found out. We are trying to find the marginal revenue. So it is 17 minus 3Q into Q. That is, let me just solve it here. This chart I can remove now. I can solve it here. So marginal revenue, MR, is equal to DDQ 17Q minus 3Q square. 17Q minus 3Q square. This is equal to 17Q. DDQ of 17Q is 17. So I write 17 minus DDQ of 3Q square is 6Q. 3 into Q square is 6Q. 3 into Q square. So 2 into Q to the power 2 minus 1. So that gives you 2Q, and into 3 is 6Q. So 17 minus 6Q. This is nothing but the marginal revenue. So this was a question from the model test paper. Okay. Now this is an interesting question. Total cost is given. So this was question on marginal cost. There also we know some simple formula that total cost, if you know, say TCU is given, right? So we know that average cost is nothing but total cost divided by the number of units. Marginal cost will be equal to DDX of the total cost, derivative of the total cost. So these are the three important relations. Now in this question, the total cost is given. The total cost of the company is Q cube minus 4Q square plus 12Q. This is the total cost function. You have to find average cost. So I'll just rub it out. You have to find the average cost. So number 1, you have to find average cost. Number 2 is you have to find the marginal cost. And you also need to find the situation when average cost will be equal to marginal cost. You have to find at what value the average cost will be equal to marginal cost. Right. So these are the three questions which you need to solve. So I have the total cost equation Q cube minus 4Q square plus 12Q. This is the total cost. First, I will try to find the average cost. So number 1, average cost, AC, average cost. is equal to total cost by quantity. Right? If I say that my total cost is 300 rupees and I am producing 5 units, what is my average cost? 60 rupees. How do you get it? 300 by 5. So total cost by the number of quantity will give you the average cost. So this is equal to q cube minus 4q square plus 12q divided by q. So that gives you how much? Q square minus 4q plus 12. This is the first part. This gives me the average cost. Please see, I have divided the total cost by the number of units, that is by the quantity, so that we get q square minus 4q plus 12. This is what we got. The second question is you have to find marginal cost. Okay. Now we know that marginal cost, second point, we know that marginal cost is equal to what? DDQ of total cost. That means the differential coefficient of the total cost with respect to the quantity. Total cost is given q cube minus 4q square plus 12q. So I'm trying to find the differential coefficient of that. So what will happen is DDQ within bracket q cube minus 4q square plus 12q. This gives me q cube. This will become 3q square minus 4 into 2, 8 cube plus 12. This will be the second answer. That is, this is the marginal cost. So we have found out the average cost. As per the question, average cost, it is done. The marginal cost computation is done. And the only point which is left is to find out at what quantity the average cost is equal to marginal cost. So if I know the average cost is this and the marginal cost is this, so I have to equate them. I will equate the two equations, the two expressions, and we'll find out at what quantity level they are same, right? So let me just equate them, and let me do it here. Just rubbing this formula. Let me do it here. So we are solving the third part, okay? Solving the third part. So I will equate both of them. So I write q square minus 4q plus 12 is equal to 3q square minus 8q plus 12. Okay, let me check whether it's same or not. Okay, just check whether it's correct or not. So on both sides, we are having q, 12. 12 and 12 cancels out. So I have 3q square minus q square comes to this side. So 2q square is equal to 8q minus 4q, that is 4q. So from here, we can write 2q square is 4q. So q cancels out. We have 2q equal to 4. So q I'm getting is equal to 2. So when the number of units is 2, then at that condition, the average cost will be equal to the marginal cost. So we have solved all the three parts of the question. So you can see that differential calculus is having a wide applications in economics. And of course, economics means we deal with cost, demand, supply, revenue, revenue function, cost function, profit function. And this is where differential calculus is highly used. Right. Okay, we will take the last one, and this is regarding the elasticity of demand, right? And this is, of course, something which you have already studied in economics. So basically, it deals with the price elasticity. So we will just do a question on that. Just see if I can share one more question. Okay. Cost function, average cost we have done, marginal cost we have done, fine. Okay, yeah. Revenue function also we have done, okay. Okay, let's see one example. This is page 8.17. Please move to page 8.17 of the study material. Let's do this one, and then we will see the elasticity, which is the last part. Or rather, let me do the elasticity first, and then we will end with this numerical. Okay. So demand changes with price. We can understand that demand changes with price. So demand definitely changes with price. Okay. So elasticity of demand is what? How elastic, right, the price and demand relationship is. So if I say that if my income falls by 10%, right, I might definitely cut down my expenses on luxury items. So the demand will be highly elastic. In other words, if my salary, say, for example, is the price, let's talk of price and demand. If price increases by 10%, maybe I will reduce my demand by 20%. So 2 times, very high elasticity. 10% increase of price, I reduce my consumption by 20%. If price increases by 10%, say my friend reduces his consumption by 60%. So elasticity is 6. Here elasticity is 2. If I say that price increases by 10%, but I reduce my consumption by 5%, that means price elasticity is half. Okay, so you can see that this is the concept of elasticity with respect to the price. What is the impact on demand? But this is possible. These examples are possible for luxury items. Now imagine for necessity items. Now you have to ride your bike every day, say for example, you have to drive your car. Even if the fuel price increases, can you buy lesser petrol? No, you have to cover the same distance. Can we buy less quantity of food items, even if say for example the price increases? No. So we go on buying the same number of units because in case of necessities of life, like food items, like basic clothing, we call it is inelastic. Inelastic. That means as price increases, demand does not change much. But in case of luxury items, as price increases, people react instantly by cutting down on their consumption. So when price increases, say by 10% or 20%, maybe the consumption comes down by 40%, 2 times. Okay, so this is how we can think of elastic, inelastic versus elastic. So this is the basic economic concept. Now, in the language of calculus, how do we write it, right? So we can say elasticity is nothing but the proportional change in the demand by the proportional change in the price. So I can write proportional change in the demand divided by the proportional change in the price. That is what I was discussing. So proportional change in demand means delta Q by Q. Proportional change. Original change, the original quantity is this, change is delta Q. Right? Similarly, the proportional change in price can be written as delta P by P. So the formula, if you simplify this, is delta Q by delta P into delta Q by delta P into P by Q. This is the final formula, where delta Q is the change in quantity, delta P is the change in price, Q is the original quantity, P is the original price. So this is the concept of elasticity. So we also write that we have discussed about the elasticity of demand, ED. So you can see economics and calculus, they are speaking the same language. The concept is uniform and calculus is interpreting economics. The formula of differential calculus is used in interpreting economics. So once you go to higher level of economics, you will find that huge, extensive use of calculus is used to explain the different formula in economics, in production, in labor theory, right, in income. So everywhere for explaining basic concepts like revenue, cost, profit. we can see extensive use of calculus, but it's mostly differential calculus. And this is the elasticity of demand. And I was discussing about inelastic demand as well as elastic demand. Okay. We come to the last question, and I can only tell you that what we've written here, d delta q by delta p. I think now in our language, as per our discussion today on differential calculus, I can just write it as dq by dp into p by q. Okay, so this will be, I will put it in blue color because it is something we have learned today. This is the concept in economics, and this is the concept in calculus. It means the same. Delta q by delta p, and here dq by dp remains the same. The concept is same, the way of interpreting is different, but now I hope you can see that everywhere differential calculus measures the rate of change. Everywhere, rate of change. Acceleration, I gave an example. Here I gave the example of elasticity. It is just measuring the rate of change in what? In the dependent variable due to a change in the independent variable. So here you can see the independent variable, if you see, is what? The independent variable is what? As price increases, my quantity falls. So here the independent variable is the price and the dependent variable is the quantity. Okay. So dq by dp means what? The concept is what? The change in the quantity. Quantity is the dependent variable due to a change in the price. Price is what? Price is what? Price we can write as the independent variable. Right. So I hope you have understood. So when we say that the elasticity, I was saying, elasticity, the elasticity is 3. That means elasticity is more than 1. If the elasticity is more than 1, we call it elastic. If the elasticity coefficient is more than 1. If the ED is less than 1, then we call it inelastic. Like I said that even if the price increases, the consumption for necessary items, food items, will not change. So it is inelastic, right? So that is elastic and inelastic. Lastly, we look at the last concept is, we'll just take one numerical and we will try to conclude. Okay, so let's take this example, which is there in page number 8.17. So we had extensive discussion, detailed discussion on economics, and you can see the common point of calculus and economics. So please see 8.17 of the study material. Page number 8.17. Kindly go to page number 8.17 of the study material. And let us see what will be there. Okay. Computer software company wishes to start production of floppy disk. It was observed that the company had to spend 2 lakh for the technical information. And so 2 lakh rupees, 2 lakh for the technical information fine, and cost of setting up the machine is 88,000. So 88,000 is the cost of machine setup. Machine setup is 88,000. Okay. Cost of producing each unit is 30 rupees. So unit cost, okay, I'm writing unit cost is 30 rupees. And sale price, SP, is equal to 45 rupees. You have to find the total cost function and the break-even point. So we have to find the total cost function and the break-even point. Now the total cost function, you can see, is very simple. We can write that total cost is equal to, fixed cost plus variable cost. Everyone knows about it. Here fixed cost is how much? Technical information 2 lakh. And machine setup is 88,000. So total fixed cost is, I can write 2,88,000 by adding up 2 lakh and 88,000. The unit cost is 30. So to produce 1 unit, you are spending 30 rupees. So to produce X units, okay. So to produce X units, I can say you will incur 30X. So I can say the cost function Cx, that is the cost function. Okay, the cost function I can write simply in this way: 30x plus 2,88,000. This is my cost function. I think it is clear to you. Cost function means the variable cost and the fixed cost. Here the fixed cost is 2 lakh rupees for technical information, 80,000 for machine setup, 2,88,000. And we have 30x. This 30x is basically the variable cost, which is unit cost is 30 rupees. I am producing X number of units, so 30x. So total cost is 30x plus 2,88,000. This is what the variable cost, this is fixed cost. So I have found out number one is done. Second question is, what will be the break-even point? Now you know break-even point. Second question, BEP. The break-even point is reached when the revenue is equal to the cost. Now I have revenue, selling price is 45 rupees. So if I am producing X units, I have to find at what level the revenue will be equal to cost, right? Revenue equal to cost. That means at break-even point, the profit is zero. I'm earning as much as I'm spending. So revenue is equal to cost, profit is zero. So I will just equate and then I will check what is the, what is the solution to the equation. So if my selling price is 45 rupees per unit, and if I'm selling X units, my total revenue is 45X. And for X units, my total cost is this, 30X plus 2,88,000. So from this, I can solve for X. 30X comes here. So I get 15X is equal to 2,88,000. Let me calculate how much is X. 2,88,000 divided by 15, I am getting 19,200. So X is equal to 19,200. That means at 19,200 units, the company will reach break-even point. And you can easily understand, lower the break-even point, better it is. Higher the break-even point, it means the company has to produce more to reach no profit, no loss scenario. So every firm, every company must target towards reducing the fixed cost so that the total cost comes down, which means that the break-even point can be achieved earlier. The break-even point can be achieved sooner in time by producing less number of items, right? So that is the break-even point concept, and we have solved this question. Please go through 8.17 page number and see whether you understand these questions. So finally, friends, we wrap up. We had done extensive discussion. We started with functions. We discussed about the dependent variable concept, independent variable, derivative concept. In 2 hours, we have done maximum. So you can see, as per the time allotted, already we have overshot. It's almost 4:20 now, right? It takes so much of time to understand the chapter. So for solving exercise questions, it will take additional time, but we don't have that time, right? So you carry on. If there are revision classes at the end, we can take it up. Otherwise, we have a tight schedule. You have got every day's routine. Next day, we have to start with integral calculus. And in 2 hours, we have to complete integral calculus also. So we have, just to wrap up, derivative we have done. I gave examples of rate of change, acceleration, price, income, consumption. Then we looked at the concept of continuous function, formula, the fundamental formula, sum of differential coefficients, subtraction, product rule, division rule, also known as the quotient rule. Then we looked at each of the 9 formula. Thereafter, we went into implicit functions. We took numericals on parametric functions. Then we took up multiple differentiations up to 3rd order I have discussed and showed with you. Then after that, we discussed about curve, tangent, and we did solutions on finding out the tangent to a curve. Thereafter, we went into the discussion of demand, supply, cost, revenue, and profit. Then we discussed in detail on the price elasticity of demand. I was talking about this particular equation which I wrote, that ultimately the concept of ED, that is elasticity of demand, is nothing but dQ by dP into P by Q. So you can see that this concept is basically the concept which we get from differential calculus, and it is something which agrees with the basic principles of economics as well. And later on, we discussed about this numerical to show how we are able to get the break-even point, right? So it's a long journey we have covered. derivative concept, addition, subtraction, product rule, quotient rule, implicit function. We also took log, examples of log, parametric functions, tangent, slope, gradient I explained, higher order derivatives and applications of derivatives together with discussion on economics. So with that, we come to the end of today's session. Hope you have seen and understood the concept which I have tried to put in front of you within, of course, as much as possible within the given timelines. We have exceeded the time given to us, but still I hope that you have followed it. Next page, we will meet to discuss on integral calculus. That will be the end of the mathematics portion. Integral calculus also is just the opposite of differentiation. Here we are differentiating, breaking down. There we shall integrate the reverse process. But there will be a number of formula which you need to remember. So please go through the discussion, see the video once again if possible, and try to clarify your doubts and your concepts by practicing more and more. Go through the study material. Till we meet, thanks for watching.